Hello everyone, welcome back to another AP Physics 1 daily problem. Today we'll be going over question 5 for dynamics in the MIT AP Physics 1 workbook. That'll be in the description down below for you guys to work on as you watch this video. And with that being said, let's go on with question 5. It says a ball falls straight down through the air under the influence of gravity. And there is a retarding force F on the ball with magnitude given by F equals bv, where the v is the speed of the ball and b is a positive constant. The ball reaches a terminal velocity after a time t. The magnitude of the acceleration at time t over 2 is, and then we have our answer choices. So here we have a ball, and the ball is falling with the influence of gravity, meaning that we have force gravity pulling down on it as it travels down. And here it says that we have a retarding force F on the ball, which is given by F is equal to bv, and this is and b is a positive constant and v is the speed. Knowing this information, we can go ahead and set up our Newton's second law equation, which is F equals mass times acceleration, and to be more precise, F, which is F net. F net is just all our forces acting up, where we add them up based off their direction component. So here the ball is traveling downwards, and since force gravity is also in the direction of the force gravity in this case is going to be our positive. So it's going to be force gravity. So positive force gravity, and here we have our retarding force, and that means it's going to be a force that is acting against the motion, trying to slow down the object. And since that it is trying to slow down, it's going to be acting in the opposite direction, which is force F, meaning it's going to be minus F, and it's going to be equal m times a. Now what we need to do is get a by itself, because we're trying to find the magnitude of acceleration, and to do that we need to find a relationship for acceleration. So doing that, we would divide by m and divide by m and divide by m. Divided by m, we have force gravity, which is also equal to mg, so that would be mg, so this can be mg, so I would just cancel out the m's, and then we would have g minus force over m is equal to a, and this force is also equal to bv, so we can replace force as bv, so giving us the relationship over here as acceleration is equal to g minus bv divided by m. Now if we look at our acceleration's relationship, we can see that the acceleration at time t, which is the terminal velocity, is going to be 0. And the reason being, at the terminal velocity, the object has reached its terminal velocity, right? And since it's reached its terminal velocity, it's not going to change, meaning that it's going to stay that constant acceleration, which means that acceleration is going to be equal to 0 at time t equals t. At time t equals t, right? It's going to equal 0, the acceleration. And if it's asking us that time t half, so half of that time, we know automatically that half of that time it's not going to be d, because d says it's going to be 0. And if we're not even fully at the terminal velocity, then we know that it's going to be it's not possible to be 0, meaning we can cross out choice D. Now that leaves us with our choices A, B, and C. And I would say we can cross out choice C also at this point, because it's giving us a solid value and we don't really have any numbers to plug in. So saying that it's equal to 10 meters per second squared is not something that we can just assume. So we can cross out choice C, leaving us with choice A and choice B, increasing and decreasing as our choices. And as we can see, our relationship, as we said earlier, is acceleration is equal to gravity minus bv, and b is a positive constant and v is the velocity over m. And if we manipulate this equation just a tiny bit and we rewrite it as acceleration is equal to gravity minus b over m multiplied by velocity, which is just the same thing, but now we're getting the velocity by itself, because velocity is a big thing in this problem. Now if we notice that velocity, right, as time goes on, as the ball keeps falling down, the velocity is just going to increase and increasing until it reaches that terminal velocity, and that terminal velocity is going to be way greater than its starting velocity, meaning that the velocity over time has to increase. And knowing that the velocity over time has to increase, that means that this side, since it's multiplied by velocity, is going to also increase. And if we remember, gravity is a constant, 9.8 meters per second squared. And this constant of 9.8 meters per second squared is going to be minus by something that's increasing over time. And if you have a big number, right, minus a small number, that number is going to be big or positive, right? But if we have a big number minus a big number, it's going to be negative or very small. So going based off that logic, as v increases, as this increases, so as we have a big number minus a small number getting to a medium number to a small number, is going to start to decrease. So for example, plugging in numbers, let's say 9.8, and let's say this ends up being 1. This is going to equal 8.8. If we have 9.8 minus 2, this is going to be 7.8. And as we can see, one more time, 9.8 minus 3, this is going to equal 6.8. As you can see, the value keeps decreasing, and this value is acceleration. And that means that the acceleration is going to keep decreasing as time goes on. And as time goes on, since the acceleration is decreasing because the velocity increases, we know that at time t over 2, so halfway to the terminal velocity, that it's going to be decreasing. The magnitude of the acceleration is going to be decreasing, which leads us to choice B, because choice A is incorrect because it's saying increasing, which is not true. That'd be true if the velocity was decreasing over time, but that is not true because as the ball is falling, it's getting faster and faster and faster, leading to this gravity constant getting subtracted by a bigger number as time goes on, causing acceleration to decrease. I hope you guys enjoyed that video. If there's anything in there that didn't make sense or you wanted me to clarify on, please comment down below. I would love to respond to them. And as I always say, make sure to enjoy life, and I hope you guys enjoyed the video. Thank you.